Hi, Shahad. So here we have a couple of questions on calc. Wondering if for all, no, or some real numbers, cases A through E are true. I know that B specifically is highlighted, but I'm gonna assume that that's a problem on the website's end, just in case you wanted help on all of them and the website screwed it up. If you just want B, then stay tuned for about 30 seconds. So for A, we have a situation that is true at x is equal to 0, because then we have 2 to the 4th, 16, being equal to 0 plus 16. But it's false at, for example, x equals 1, where 3 to the 4th is 81, which is not equal to 1 plus 16, which is 17. So A is true for some real numbers, x. For letter B, this one is going to be true for all, because x squared plus 4 squared is x to the 4th plus, that looks like times, plus 8x squared plus 16. So the square root of the right would equal the inside of the left, so this is true for all. For letter C, we find that this equation is true when x is equal to plus or minus about 3.37, I believe. Yep. And so these equations hold true for no x's. Give an example, because if you take either plus or minus 3.37x, neither of them satisfy this equation. For D, for functions f and g, if they're both even, then their sum is even. And remembering about even functions, let's start this over. Remembering about even functions, that they are functions that are symmetrical about the y-axis. And this is represented by the equation f of x is equal to f of negative x. So this is the definition of f being an even function. It says that if you go x over to the right, your function will be at the same height as if you went x over to the left. And so to prove that the sum of two even functions is even, well, we would start with the sum of two functions. So let's take f plus g of x. And because these are sums of functions, we can split them up. This is equal to f of x plus g of x. And because these are even functions, both of them, we can write these now as f of negative x plus g of negative x. And this can now be rewritten as f plus g of negative x. And now what we've done here is we've shown that f plus g of positive x is equal to f plus g of negative x. So this is true for all real x. And for E, we have for values of k, x, and y, if x is less than y, then kx is less than ky, where k is a constant. And this seems to be true for all, but you need to remember that k is any constant. So for example, if let's let x equal something easy, 2, and y equal something like 3. So at k, or when k is equal to 1, then yes, k times x is 1 times 2 is 2, which is less than 3, which is k times y. But at k, that one's gross, at k equals -1, well, now we have k times x equaling -2, which is not less than -3, which is k times y. So E is true for some. And there you have it. If you have any questions, feel free to let me know.